Good morning, everybody. Myself, Acharya Vishvendra, and today I am going to discuss a worksheet on stress and strain. So let's begin with things. So here is the worksheet. The first question is dimension of stress. So dimension of stress is m1 l minus 1 t minus 2. Next is dimension of strain. So it is m0 l0 t0. Next is dimensions of Young's modulus. It is m1 l minus 1 t minus 2. Next is dimension of energy. It is m1 l2 t minus 2. Next is dimension of energy density. So it is m1 l minus 1 t minus 2. Next is stress is equal to, so stress is equal to magnitude of force per unit area. Then we have types of stress. So there are three types of stress. Then we have strain. So strain is equal to change in parameter by original parameter. Then we have types of strain. So there are three types of strain. Then we have ratio of stress and strain. We call it as coefficient of elasticity. Then we have Hooke's law. So Hooke's law states that stress is proportional to strain. Then we have a stress strain graph. So it is a straight line, and E is equal to stress by strain, which is equal to tan theta. Here theta is to be taken with the strain axis. Then we have a stress strain graph for three different materials. Suppose it makes angle theta 1, theta 2, theta 3 with the strain axis. Then we have theta 3 greater than theta 2 greater than theta 1. That is tan theta 3 greater than tan theta 2 greater than tan theta 1. So E3 greater than E2 greater than E1. Then we have another stress strain curve for two different materials, and it makes angle theta. So we need to calculate, the first thing is Young's modulus of A. So theta is to be taken from strain axis. So here angle will be 90 minus theta. So Young's modulus will be tan of 90 minus theta, which will be cot theta. Then we need to find YB, which is tan theta. Ratio of Y and YB, it is cot square theta. YB upon YA tan square theta. Types of modulus of elasticity, there are three types. Next is energy density, which is energy by volume. Then we have energy density as half into stress into strain. It is also equal to half Y into strain square. Then we have energy density is stress square by twice of Y. Then we have graph of energy and stress as a straight line under constant strain. Then if we have three different graphs, then tan theta is proportional to strain. That is here theta 3 greater than theta 2 greater than theta 1. That means tan theta 3 greater than tan theta 2 greater than tan theta 1. So strain for 3 is greater than strain for 2 greater than strain for 1. Then we have energy density versus strain graph. So that will again be a straight line, and tan theta being equal to stress by 2. Then we have three different graphs. So corresponding to the greatest angle will be having greatest stress. And at last, if we draw graph between energy density and strain, so E is proportional to strain square, the graph will be a parabola like this, and so we can solve this as. So these are the basic worksheets just developed with the vision that you start working from the very basics, because I have observed that in many coaching and school programs, the level of questions that teachers often discuss, most of the students are not able to adapt to that suddenly. So they need a sort of bridge course that bound them, or that connects them from the basics to the higher level questions. So this is the basic vision behind developing these videos. Thank you and have a nice day.